Hello guys, so welcome back to my YouTube channel. So in this video I'm going to solve this problem, right? So here it says u is ln x square plus y square, right? So show that u is harmonic on its domain, right? So B1, right? So what is harmonic? So if a function is harmonic, the Laplacian of u is equals to 0. So what is Laplacian? U is a function of x and y, right? So uxx plus uyy equals to Laplacian of u. So this should be 0, right? So I need to show that the summation of these two things are equals to 0, right? So I know that u is what? ln x square plus y square, right? So what is ux? It is partial differentiation of this function respective to x, right? So it is 1 over x square plus y square times 2x, right? Which is equals to 2x over x square plus y square. So what is uxx? It is equals to 2, let's take 2 outside of here, so it is x square plus y square to the power 2 times, so x square plus y square times 1 minus x times 2x, right? So this is 2 times y square minus x square over x square plus y square. Okay, so similarly, since this is identical, I can write uyy by looking at this. This is equals to 2 times x square minus y square over x square plus y square. So Laplacian is uxx plus uyy, which is equals to 2 times x square plus y square minus x square over x square plus y square plus 2 times x square minus y square over x square plus y square. So by solving this, this equals to 0. So Laplacian of u is equals to 0. So if the Laplacian is equals to 0, this implies u is harmonic. So let's go to the second question. It is find another function v such that v is harmonic conjugate to u. So for that I need to use Cauchy-Riemann equations, right? So what is Cauchy-Riemann equations? Cauchy-Riemann equations. So Cauchy-Riemann equations are ux equals to vy and uy equals to minus vx, right? So these are the Cauchy-Riemann equations. By using these two, I'm going to find the function v, right? So I'm going to find v using these two equations, right? So I know that u is equals to ln x square plus y square, right? So ux equals to, it is 2x over x square plus y square. I have found that here, right? So this should be equals to vy, right, by Cauchy-Riemann equation. So I know that vy equals to 2x over x square plus y square. So I'm going to integrate this one. So this is equals to 2x over x square plus y square dy, which is equals to 2 times, here x is a constant, so I can write 2x, 1 over x square plus y square is what? it is 1 over x times tan inverse y of x, right? Not tan inverse, it is tan y of x, right? Plus constant, right? Here x is a constant, so this should be a function of x. Okay, so x to x cancel out, so v equals to 2 tan y of x, right? Plus gx. Now I am going to differentiate this one. So now I know that vx equals to minus uy, right? So now I am going to differentiate this using respective to x, right? So vx equals to 2 1 over 1 plus y of x square times differentiation of y, differentiation of x, which is equals to y, right? Plus d dash x. So I know that vx equals to minus uy. So uy is what? Uy is 2y over x square plus y square. So this is equals to 2y over x square plus y square equals to, here when I simplify this one, I get here I am going to differentiate using x, right? So it is minus y of x square, right? So this equals to vx equals minus uy. So this is equals to this time equals to minus x square to x square cancelled out. So this equals to minus 2y over x square plus y square plus d dash x. This cancels out. So g dash x equals to 0. So this implies gx is a constant function, right? Okay, so I have found that gx equals c, and here c is a real function, real constant. So yeah, v equals to here it is simplified 2 tan y of x plus c, right? So this is the conjugate of x, right? Yeah, so the answer for the second question is this. I hope you guys understood what I did in this question. So if you guys have any questions, please comment below. Thank you for watching.